Hello everyone, I'm Alexander Schaap. I'll be your host for today's webinar. On behalf of Furukawa, we welcome you to the webinar How to Set Up a Laserway Pre-Project. Furukawa's Laserway technology has revolutionized the telecom market for enterprise, hospitality, education, airports, and many other segments. Bringing fiber optic to the office has provided a great technological evolution in the workplace. I present you my colleague Thalita Favoreto, who is a telecom engineer graduated from the Federal University of Paraná. She works with application engineering for passive optical LAN, structured cabling, and data center solutions for Europe, Middle East and Africa and Southeast Asia regions. She has also previously worked with product engineering, network design, and as a training instructor in different Furukawa's marketing verticals. During the presentation, please feel free to ask questions in the comment sections, and we will address them at the end of the presentation. Thalita, please take over.
Thank you, Alexander. So before we start talking about making a Laserway pre-project, I will tell you about a little bit about Furukawa Electric Group. So here we go. Furukawa Electric Group is a Japanese company with core values. We are 50,000 employees around the world, and we have 120 subsidiaries in the 5 continents. We have annual $9 billion in revenues, and we have ISO certificates for quality, environment, occupational health and safety management systems. So Furukawa Electric Group exists for more than 140 years in the world, and in Latin America we are for more than 40 years. So we have solidity in several market segments, and we keep working in updating and developing our knowledge base, always looking for developing innovative solutions. So we have these main 2 product solutions: FCS, Furukawa Connectivity System, for cabling systems, structured cabling systems, for enterprise, for data center, which is included the Laserway solutions that we are commenting today. And the other product solution is FBS, Furukawa Broadband System, that has the solutions for FTTX applications, so mainly for telecom operators and internet service providers. So to start to talk about Laserway solution, let's take a look on the general concept of a passive optical LAN. So passive optical LAN, or PON LAN, is a optical local network. So the main characteristics of this network is that the only active equipment that we have in this network are the OLT, optical line terminal, at one end, and in the other end we have the ONUs or ONTs, optical network units. These are the 2 active equipments. The rest of the products, they are passive products. So they are optical cords, optical cables, optical splitters, and other devices to terminate to install these optical fibers. The communication in this network works in the downstream in one wavelength and in the upstream in another wavelength. So it's possible to have two ways of communications in the same one fiber. So we are not talking about duplex communication, duplex fibers. So it's only one fiber. And another characteristics that it's possible to split these fibers up through these optical splitters. So for example, we have one fiber going out from the OLT, and this fiber is split up to 32 other fibers, or 64, depending on the application and depending on the design of the project. And also another important feature of the PON LAN is that we can achieve larger areas. In general, we say 20 kilometers because this is the distance between the first ONT and the last one, but it can reach up to 60 kilometers. For Laserway application, and usually we don't need this huge area, but the FTTX or the PON LAN technology possibilitates that. And from the ONT to the devices or users, we make the connections through copper cable, through copper patch cords or cabling. Now talking more specifically about the products of the Laserway pre-connectorized solution. So here we have the OLT installed in the equipment room, and in the other side the ONTs installed in the work areas, right? So here we have a model of ONT that is connecting 4 IP devices. We have 4 gigabit Ethernet ports, and beside these 4 ports we also have 4 ports to connect analog telephone, and another model of ONTs that we can connect up to 4 IP devices and also implements power over Ethernet features. So these devices that they can be powered up with power over Ethernet. All this through category 6 patch cords, regular category 6 copper cords. Coming back in the equipment room, so the OLT is connected through the uplinks to the cloud, to the external communications, and for the Laserway network, from these GPON ports that we have in the OLTs, we connect one optical splitter here in one LGX cassette like this one. And then from the back, the rear part of the LGX cassette, we connect the services or trunk cables. So these are optical cables that are connectorized in both ends with MPO connectors, and one side is terminated in this LGX cassette here, which is the splitter, and in the other side at the other LGX cassette that we have in the work area. So in this case, we are talking about the base 8 solution. So we have 8 fibers in this trunk cable and also 8 fibers in this cassette. This cassette makes the transition of one MPO connector in the rear part of it to the SC connectors that we have in the frontal part of the cassette. Here it's showing 12 fibers, but we are talking about the 8 fibers. So please consider we have 8 fibers here. So from this cassette, we can connect up to 8 ONTs then from this part. In this slide, we have more details about the products. So here we have the 2 models of ONTs, this one that supports power over Ethernet application, and this one that besides the 4 Ethernet Ethernet ports, we have also analog ports, analog telephone ports. And here I would like to show you the rear part of the LGX cassette with the splitter inside. So we can have one or two inputs for this splitter, and in the rear part we'll have 4 MPO connectors with 8 fibers each. So 4 times 8, it gives us 32, the 32 outputs that we have in the splitter. These LGX splitters, they are installed in these optical patch panels that can fit up to 3 cassettes. And in the work area, the transition cassette is installed in these connection boxes. So these connection boxes can be installed in the pathways that we have in the installation. And about the models of the OLTs that we have. So we have this first model, standalone, occupies 1 unit of rack, and it has up to 8 GPON ports. And the other model occupies 2 units of racks, and it has 2 slots. Each slot has up to 16 GPON ports. So this gives us 32 maximum GPON ports in this OLT. And the optical transceivers that we connect in the GPON ports, and other models for the uplinks. And one last concept before starting to talk about building the bill of materials and the diagrams, which is the topologies. So for Laserway applications, we have 2 possible topologies. The first one is the centralized, and the second is the local convergence topology. The difference between these 2 topologies is the location of the splitter. In the centralized topology, the splitters are installed in the equipment room, just after the OLTs. So starting from the output of these splitters, we have a point-to-point network. So all the fibers that are used in this topology, they are available in the backbone. So it gives flexibility for this implementation. And the second topology, which is the local convergence, the splitters are installed in the floors. They are not in the equipment room with the OLT. So it gives a reduction of quantity of fibers in the backbone. That's the advantage of this topology. So having these main concepts in mind, we can talk about the designing itself. So these are information types of documents that are important to take into account when we are making pre-project design. So the more information of this that we have, the more accurate the pre-project is. But the pre-project doesn't eliminate the need for making an executive project. So it's important to make like a site survey, to go on site to see all the details for the installation, to have more accurate cable lengths and everything. All this information, they can be organized in tables and in floor plans like this. This table, for example, shows the quantity of floors the building has and the amount of data devices, voice devices, VoIP devices, CCTV, and access point devices that we have per floor. And also, here in the floor plan, we have the location of some devices. Here also data, analog telephone, IP IPTV, cameras, access points, and so on. Also, it's important to take into account the location where the where the ONTs will be located, if they will be installed under the table, on the top of the drawers, in pathways in the ceiling void, if it's on the table or centralized between the workstations, or installed inside the furniture's pathway. No? So also, besides the ONT locations, it's important to know the devices locations and the pathways, the type of furniture, if the furniture have a specific infrastructure for installing the cables and the equipments. Also know about the infrastructures of the building, pathways, technical floors, ingress from the floor to the furnitures. And it's important to have in mind that the maximum distance from the ONT to the device is up to 90 meters, because as I already commented, from the ONT to the device we have copper cabling. Here are some steps by steps, like a flow chart with the definitions that we have to make before building finally the bill of materials, but I will comment this in the next slides. So we have two methods for making the bill of materials and diagrams. The first one is the fast planning, and it's applied when we don't have all the information available. So with only this information that we have available, it's possible to make an approximate bill of materials, and then to have an idea of the budget that is required for the implementation, for the project. So with the bill of materials, we can make a financial pre-feasibility analysis and then a comparative analysis. And here are the minimum information that is required. For example, in a 6-floor corporate building, so it's important to know how many floors the building has. In this example, 6 floors. Where is the equipment room located? In this example, it will be located at the 1st floor, and the quantity of devices to be connected per floor, and also the power over Ethernet devices required by floor. So here we have represented by gray triangles the power over Ethernet devices, and in purple triangles the quantity of regular devices. Okay, and we can put these quantities in a table just like this, with the summing up the quantities of ports, regular and PoE, and we can take into account a percentage of scalability or growth. To simplify the analysis, in this case we are not considering scalability nor redundancy. And the next step is to calculate the quantities of ONTs that we have, considering these devices, these quantities of devices. In this case, we are considering a dispersion factor. So we will implement 25% more in the quantity of ONTs, because we are considering that not all the devices, the ports, they are grouped, they are concentrated. So we have these ports spread all over the network. So for ONT, regular ONT, not PoE ONTs, we will consider the quantity of devices divided by 4, which is the quantity of ports that we have in the ONT, and more 50% of dispersion factor. In this floor, for example, that we have 56 devices, rounding up, we'll have 18 ONTs, and we'll make the same for the other 5 floors. And also for ONT with Power over Ethernet implementations, applications, we will consider a dispersion factor of 50%. So in this 6th floor, we have 10 devices divided by 4 with 50%. Rounding up, we will have 4 ONTs in this floor. And we'll make the same calculation for other 5 floors. Besides calculating the quantities of ONTs on each floor, we also will calculate the quantities of connection boxes that we have by floor. So we'll take into account the quantities of ONTs and then divide by 8, because this is the quantity of ONTs that one connection box can attend. And the same for splitters, as we are considered 1/32 splitter in this design. We will divide the quantity of ONTs by 32. Okay, so making these calculations and considering the topology as decentralized, we'll have the distribution of connection box by floors, and then the quantity of splitters that are needed per floor. But it doesn't mean that the splitters are installed in the floors, as we are considering the centralized topology. So with all these quantities and part of the products needed, we can build this table of quantities. So we have here the 6 floors that we already saw, the quantities of parts that were already in the first table, the number of ONTs that we calculated, and having the quantities of ONTs, it's possible to know the quantities of work areas cords, because we need 1 cord for each ONTs, so it's easy to know. We already calculated the quantities of connection boxes, and with the same quantity, we will need the LGX cassettes and the trunk cables. And by the number of the splitters, we are able to know how many patch panels will fit these 10 splitters, as it has the capacity of 3 modules, and the same quantity of transceivers for the OLT and UPC cords to connect these transceivers from the OLT to the splitters. So here we have all the products and quantities that are needed to make the bill of materials. Before making the bill of materials, we can also make a line diagram. So it gives us the idea of each part of the OLT is connected to how many splitters and how many connection boxes and how many ONTs. So with the same representation of the colors that we used for the floors, so here it means that the first OLT port is connecting 1 splitter for the floor number 1, and for the floor number 2, 2 splitters are required, so we are using OLT ports number 2 and 3, and so on. So this is the line diagram. And finally, the bill of materials. So we will translate all those products and quantities in part numbers and products descriptions. And also it is grouped by the areas that we have on the network. So coming back a little bit to the diagram that separates the equipment, the products at the equipment room and the products in the work area, we can see the same division here in the bill of materials. So in the equipment room, we have OLT, transceiver, optical cord, splitter, patch panel. We have the trunk cable connecting the equipment room to the work areas. In the work areas, we have the cassettes, the connection box, the cords, the ONTs, and at last the patch cords. So this is how the method 1 works. For the method 2, it works at the same way, but we also have the floor plans. So having the floor plans, it's possible to locate the devices in the floor plans, to count them and to group them in 4 or in other quantities, to define and to locate the ONTs in the floor, and also the connection boxes. So here let's take a look at this region example of a cell. So this is the same work areas that we have. Here we have represented the devices in red triangles. We are grouping up to 4 devices around 1 ONTs. In this example, we have 4 devices. In this one, we have 3. In this one, we have 2. So grouping up 8 ONTs, we can have a connection box to attend to serve this area, this cell. So we have around 1 connection box, 8 ONTs that forms up a cell, a zone, an area. And also represented here the trunk cable connecting the connection box and going to the equipment room. Also, it's possible to build some rack bay faces diagram, because here we have the equipment that is planned for the equipment room and all the other connectors. So we know, for example, that this GPON port is connected to this input of the splitter that goes out in this MPO port in the rear part of the cassette, the module, connects up this cassette in the work area, goes up in this SC port in the rear part of the cassette that connects this ONT that finally connects this device. So making this correspondence, we can have the correspondence of ports in the equipment room to the ports in the work areas. Okay, and the last slide that I prepared today is some main reasons of why to use Laserway. So all the products, they are connectorized in factory. They are 100% tested, so we have qualified products that gives us greater reliability. And as we are talking about pre-terminated plug-and-play systems, it gives more quicker activation of new ports and work areas. Also, because it's pre-terminated solution and it's because it's a passive optical LAN solution, passive equipments, we have lower maintenance and operational costs. No active equipment is required along the network besides OLT and ONT, so it has less chances to have problems with active equipment along the network and less maneuverings also. And as we are talking about optical systems, optical products, gives us more a longer life cycle of cabling, because in case we have technological updates, one thing we can do is to update the active equipments. The rest of the network, which is optical fiber and optical products, they keep installed and support these technological changes. Right, that's what I had to comment with you. If we have any questions.
Thank you, Talita, for the presentation. So we still have some minutes to answer a few questions. first question is from X. Could you please explain about dispersion factor for POEONT again?
Okay, I will come back to the slide that we talk about the dispersion factor. Okay, so the dispersion factors only means that we are not simply taking the quantity of ONTs that we have and divide by 4. Besides that, we will foresee 20% factor for extra ONTs. It could happen that we don't use this dispersion factor, so we could simply divide 18 ONTs by 4, which is the quantity of ONT ports, and we'll round this number up, and then we have the quantity of ONTs planned for this floor. Oh, sorry, it's not 18 that we have to divide by 4, but 56 by 4, and then one factor of 50%, or not to consider a 50% factor for the quantities of ONTs.
Okay, thank you, Talita. Thank you, X, for the question. We have a couple questions from Luis. The first one, what is the recommended size for a work area in a Laserway project?
Okay, going to the other diagram. Sorry. Okay, in this one, right? So here we have the connection box, and from this connection box we will connect the ONTs, right? So the recommended, as we are using the optical solutions, we don't have a defined length for that, because as we have the PON feature of having 20 kilometers up to 60 kilometers in area, it's possible to have this wide area. But the important thing in this application, for example, office implementation, is the distance between the ONT and the connection box. So here we have the connection box installed very close to the ONTs. The only recommendation that we have to take into account is the distance between the ONT and the devices, because as it's copper cable, a category 6 patch cord, or a copper cable that is implemented between the ONT and the telecommunications outlet. So the maximum length, because of the copper cabling, is 90 meters. But when it's optical, we don't have this constraint. We don't have this restriction.
Thank you, Talita. And the next question from Luis is, what is the most used topology for Laserway?
Okay, so taking those two possibilities, local convergence and centralized. So it depends it depends on the quantities of ONTs that we have implemented, right? If you have around 32 ONTs implemented by floor, or a quantity that is multiple by 32. The local convergence topologies is interesting because in this way you can use all the splitter ports that you have. It would not be interesting, for example, if you would have like 10 ONTs in this floor and then 10 on the other, because you would be subutilizing the splitter ports. So it depends on the quantities of the ONTs that you will have implemented by floor, and if this quantity is multiple by 32 or multiple on the splitting ratio that you are using, depending on the splitter. As in Laserway, we usually use 1 by 32, so 32 is the number that you have to consider.
Thank you, Talita. Thank you, Luis, for the questions. In case you have other questions, they can also be sent directly to Talita's email afterwards, and she can address them later. After this webinar, you'll also receive a link to the video of this webinar, which is recorded, that will stay available for you to watch again. So we thank you, Talita. Thank you, everyone, for participating in this webinar, and we hope to see you again on the next ones. See you soon.
Thank you.